Hi, I'm Russell of Archangel Tech and welcome to Circuits 101, solving for the total resistance of a series, parallel, and series parallel circuit. To start, let's go over what an electrical circuit is. By definition, an electrical circuit is defined as a path or loop through which electricity flows. Its basic elements are a voltage source, conductors, a load, and a switch. The voltage source, in this case a battery, gives us the electromotive force or EMF in volts that causes the flow of an electron current in amps through our conductors and through our resistive load in ohms after we close the switch to complete the circuit. An electrical circuit can get a little more complicated than what we have here, but for now let's focus on solving for the total resistance. Now in our diagram, it shows only one resistance, which also symbolizes our electrical load. But what if we added another resistance connected to one end of our resistive load? So here we have two resistances connected end to end. We call this a series connection of resistances, or the series circuit. For a circuit with resistances connected in series, the total resistance is the sum of all the resistances in series. So for example, the total resistance would be equal to R plus R sub L, equal to 3 ohms plus 5 ohms, giving us 8 ohms. Let's move on to the next connection. Okay, here we have what is called a parallel circuit. In this connection, our single conductor branches out into two conductors, each feeding into a resistance, and then coming out at the other end, coming together and connecting to a single conductor. The total resistance in this type of circuit is the sum of the reciprocals of each resistance value. So for example, in our given circuit, we have R1 equal to 3 ohms and R2 equal to 5 ohms. Our total resistance, therefore, is equal to the reciprocal of 3 plus the reciprocal of 5. Now to add fractions with different denominators, we need to find the least common denominator of 3 and 5, which is 15. Then we solve for equivalent fractions that use the common denominator 15. The best way to solve this is to multiply the first term with 5 over 5 plus the second term multiplied by 3 over 3, giving us 5 over 15 plus 3 over 15 equal to 8 over 15. So our total resistance is 0.5333 ohms. The last type of connection is called the series parallel circuit. In this circuit, we have resistances connected in parallel that are in turn connected in series to another resistance. To solve for the total resistance, we need to find the total resistance of those connected in parallel first. So solving for the total resistance in our example, our total resistance would be equal to our resistance R sub S plus the total of our resistances in parallel. So that's 2 ohms plus 1/2 ohm plus 1/2 ohm equal to 2 plus 1, giving us a total resistance of 3 ohms. And there you have it, solving for the total resistance in a series, parallel, and series parallel circuit. Thanks for watching.